Hi all. See this problem which appeared in 2019 main paper, it's asked to find out the area directly, straightforwardly. So we don't have to think much. We have to find the shaded region or the required region. So what's that region? It says that is bounded by y equal to x plus 1 mod and y equal to 2 to the power x, right? So we just considered the curve, right? So the given curve, just a second, you just switch on that pane. Okay, let's go ahead. So therefore we say that the given curve is y is equal to mod of x plus 1. So what's that? That is y is equal to a straight line x plus 1 when x is greater than equal to minus 1. Okay. And it says that is equal to minus of x plus 1 when x is less than minus 1. Now see that we are talking about always in first quadrant. In first quadrant, x plus y is greater than 0. So therefore, you can consider that this is the only curve is means, right? So we don't bother about the mod now because it is always positive, right? The second curve, right? So this is obviously my first curve. And the second curve gives me that y is equal to 2 to the power x, right? Now they will intersect at some point, right? So therefore, for as x and y is greater than 0 in first quadrant, so for the point of intersection, in quadrant 1, assume two to the power x is equal to x plus 1. Now see that it's difficult to solve this kind of equation 2 to the power x plus 1, x is equal to 1, okay? But see that by observation we can see that if I substitute x equal to 1, it's done, right? So therefore we'll say that that's imply that the solution is x equal to 1 and y is equal to 2. So that will be the point of intersection, right? And also, what is the curve? Now let's try to understand that plot, right? So mod of x minus 1 will be something like that, right? Because that gives us the mod function. Now y equal to 2 to the power 2x, right? In 2 to the power 2x, right? If I substitute x equal to 0, it gives me that 1, 2 to the power 0 equal to 1. And that's why the curve will be something like this, right? So that will be the plot of 2 to the power x. Why? Why? Because see that always, right? 2 to the power x, right? Between the interval 0 to 1, right? So therefore, as x lies between 0 to 1, so therefore 2 to the power any values, 2 to the power half, 2 to the power 1 by 3, 2 to the power 1 by 5, whatever, right? It is always reduced by x plus 1 line. So that will be the approximate graph. Obviously, this distance is 1, this distance is 2, right? So let's draw the curve in a proper way. Okay, now see that we are already mentioned that plot and you see that they are the graph, right? So they are having the y-axis, x-axis and all that. And when x equal to 0, right, that x plus 1 line has one value, 2 to the power x is also have one value, right? So this is the point of intersection as well, right? So that's it. Now we understand that we are the required area is bounded by the region line x is equal to 0 and x is equal to 1. Okay, so let's mention that. So x is equal to 0 on the left. The top limit is x equal to 1. This curve will be y is equal to 2 to the power x. The bottom curve and the top curve is actually y is equal to x plus 1. So therefore, we can easily write the required area is equal to integration of 0 to 1 x plus 1 is the straight line minus 2 to the power x dx. Now this is a very straightforward integration. Let's go ahead. So therefore we can see that x squared divided by 2 plus x minus 2 to the power x divided by log 2. So these are all the formula. So therefore substitute that. So therefore 1 by 2 plus 1 minus 2 to the power 1 divided by ln 2. So I substitute that value of 1. Let's put the value of c. So 0 minus 2 to the power 0 divided by ln 2. That's imply that it gives me that 3 by 2 minus 2 divided by ln2 plus 1 divided by ln2. That's imply that 3 by 2 minus 1 divided by ln2, and that's it. So therefore, obviously we'll see that 3 by 2 plus ln2, so therefore option D is the correct answer. And that's it. Hope you understood the problem. Thank you.